Welcome back to the probability video. This is the second question we're looking at, and this one is a tree diagram, which I've already initially started, again, to save us time. When identifying a tree diagram, start with the very first branch, and important that each branch sums to 100%. So notice we're told to 23% of adults smoke cigarettes. That means this breaks into two categories. 23% smoke and 77% do not smoke, which notice I've typed out not S, but this can appropriately be used, the symbol not S. Then, all right, our tree breaks into pieces that are conditional probabilities. It's known that 57% of smokers and 13% of non-smokers develop a lung condition by age 60. So that means, given that they're a smoker, they have this particular lung condition 57% of the time. Given they are not a smoker, they have this lung condition 13% of the time. And again, each branch, 57 and 43, sum 100%, 13 and 87. So I'm not told these other numbers, but by just subtracting from one, I can fill in the entire tree. After you have that, you create what is known as the simple events. L and S, not L and S, etc. But just simply by multiplying. Again, and typically means multiply, and in this case, it's multiplying conditional probabilities. So I multiply all of these, and notice all of these probabilities also need to sum 100%. So each branch sums 100%, and the overall probabilities at the end sum 100%. So there's lots of ways to check that you're on the right track of a problem as you identify your information. So notice that before we had a Venn diagram, we have a tree diagram. The difference between them is when you have lots of conditional probabilities, you should be doing a tree diagram. When you have lots of ands and ors, you should likely be doing a Venn diagram. All right, so identifying your information is always the key start. From there, then we can again answer questions, but setup is everything. Setup takes the longest and is the most important part. So what's the probability that a randomly selected 60-year-old has this lung condition? That means the probability of L. In order to find that, go back to your picture and just identify the areas where there's L. That means that's the probability of L and S plus the probability of L and not S. Add those two numbers together. Gives us the probability that someone could have that lung condition. So again, notice that once I identify this, I actually don't use the tree anymore. From there on, you only use, all right, the simple events. I'm ignoring all this information over here, which means your tree actually doesn't have to be super well labeled as long as you have this information properly labeled. And I just added this probability and this probability. What's the probability that someone with the lung condition was a smoker? Notice what else this is asking. Now, this doesn't say given or suppose or if, right? But this implies someone has the lung condition first, right? That means this is a conditional probability. Given, all right, that person has the lung condition, what's the probability that person was a smoker? Setting up the problem, again, getting it started will always be the most difficult part. So this is where you want to put your focus. Once you've identified that, then you can identify, you can do that, and I use the definition of conditional probability to then further write out. It's the and divided by the condition piece. The condition piece is always in the denominator. And then probability of L, we just found from above, which is the 2, 3, 1, 2. And S and L, which again I can get from my diagram, 0.1311. Calculate away. And so, very important, set up your problems, take your time setting up your problems, and you can very, very easily solve any number of given questions if you spend your time on the setup. Create your Venn diagrams, create your tree diagrams, then the rest of your problems will flow very, very quickly. Thank you very much, and tune in for the next videos.